Hi everyone, welcome to our activity resource on soil erosion for grade 4 students. Your speakers for today are Veronica and Stephanie, so let's start. Drumroll please, our key concept today is soil erosion focusing on human impact or SEHI. Soil erosion is when the upper layer of soil, otherwise known as topsoil, is displaced by either water, air, human activity and other causes. From the river story, soil erosion is formed when human activity, such as that from Peter Picnicker's litter, goes into the river and displaces the topsoil, which deteriorates the surface of the soil. So why do we choose this topic? Researchers such as Wang identified human activity from urbanization as one of the main threats to soil erosion, so we decided it was important to prevent this. For primary age students, soil erosion understandings mean children will have a chance to explore the relationship between earth sciences and human impact. This understanding leads to students becoming geological agents of change, learning to become critical thinkers, and considering everyday consequences of living with urbanism.
The sequences of lessons are focused on the Year 4 students. Using the VIC curriculum, we have chosen activities based on these two content descriptors under Earth and Space Science. Some alternative conception we think students may have prior to the sequence of lesson is that soil erosion is not a serious environmental problem. Humans have no control over the rate of erosion. These conceptions may act as a barrier to students' learning. Research has suggested that students who live in metropolitan cities may struggle to understand soil is not inert, that they actually play an important role to the environment, as well as understanding that erosion did not happen in the past. By the end of this unit, we aim to help students to understand what soil erosion is, how human activity impacts soil erosion, and how can we solve this issue. The two activities that we have chosen for this topic are part of a 5-lesson sequence unit. For the Explore lesson, we'll be completing a soil erosion experiment. Students will have the chance to explore different types of soil erosion, as well as how they will impact the environment. This activity may help address alternative concepts, such as students thinking soil erosion is not a serious environmental problem. The experiment will roughly take 40 minutes, and students will be working in groups of 3. The materials needed for the experiment are listed on the right corner of the screen and will be prepared by the teacher before commencing the lesson. The focus question for the experiment is, how does soil erosion impact our environment? Before starting the experiment, students will be given an observation worksheet that they will have to complete prior, during, and after the experiment. The soil experiment requires students to first create a slope using the soil provided. Then students get a chance to stimulate the 3 types of erosion from the top of the slope. They will then observe and record any changes they will have noticed. Students are encouraged to complete the extension task, where they add different materials to the soil to create a more complex landscape and observe any differences. In this activity, the teacher's role is mainly to facilitate and challenge students' thinking and discussion using the sub-questions such as, have you noticed any changes to the soil, or what are some impacts soil erosion have on our environment? The teacher will also encourage all students to actively participate in this experiment, as well as providing opportunities for students to reflect on their learning.
For our Explain activity, we're learning to investigate and represent on a poster what human activities impact soil erosion. It will take roughly 60 minutes, and the teacher will firstly show 5 local photographs related to the river story shown on the screen and discuss with the children and write on the whiteboard how it impacts soil erosion. Students are then split into groups of 3 and 4 and assigned a human activity that impacts soil erosion to research from the above list, and given an iPad or laptop and an A3 poster for each group to decorate and brainstorm. Students should include in the poster a title, 3 ways that human activity impacts soil erosion, what happens to the plants or animals, how to solve the issue, and add drawings in the poster. This activity should reflect the focus question, which is, how does human activity impact soil erosion? This question builds on students developing understandings of what soil erosion is in the explore phase and how it impacts humans. Within this group time, the teacher should walk around the room and ask open-ended questions to gauge student thinking. The materials are listed for your reference. Finally, the role of the teacher is to mainly address alternative conceptions or challenges through familiarizing themselves with the human impact on soil erosion before the lesson, facilitating discussions, using the follow-up questions to prompt thinking, and splitting students into mixed ability groups. Firstly, we acknowledge from our own experiences and Fitzgerald and Corrigan that classrooms are diverse and learner backgrounds and context and relevance should be considered to ensure students learn effectively for age-appropriate and meaningful science learning. Both our activities are age-appropriate because they're directly linked to the Victorian curriculum. For example, the Explore activity addressed erosion surfaces, whereas the Explain activity focused on exploring the local area and addressing human impacts of soil erosion. We included the cross-curricular descriptor sustainability in English for the informative poster, as Fitzgerald and Corrigan argue that effective science learning takes place in an integrated way. Meaningful science experiences are also incorporated through the constructivist approach, engaging students through hands-on learning, for example, the soil experiment, and relevance, for example, photographs of local soil erosion places and the river story links. This practice is supported by Jakian and colleagues. The students are engaged in learning experiences which help create authentic learning to solve real-world problems. Building on the constructivist theory, we adopted the 5E model in our lesson sequence since it is effective for teaching primary science. For your reference, the engagement activity gauged students' understanding on rock, soil, and landscape. The explore phase built on students' prior knowledge of this and explored topsoil transportation to clarify any soil alternative conceptions. The explain phase was a poster on the human impacts of soil erosion and builds onto the elaborate phase, which is a field trip to a place impacted by soil erosion. Finally, this leads to the evaluation phase, where students have a summative case study on the soil erosion photos taken in the field trip and explore the human impacts and the solution to it. We also included ICT tools for poster research because we help stimulate ideas, model ideas, and present data.
In both of our experiment and poster activity, we have incorporated inquiry-based learning and cooperative learning as our teaching approaches. In both teaching approaches, they emphasize that students are the ones who are actively taking charge of their learning. For IBL, it is an approach that uses students' curiosity to scaffold their understanding. The two activities provide opportunities for students to actively explore, investigate, and discuss. This helps students to make sense of their own learning, as well as challenging their prior knowledge. Through active investigation and exploring, students will be then motivated to learn about science, which may help them to build on their scientific literacy and critical thinking skills. Similar to IBL, cooperative learning provides multiple exposure to develop students' critical thinking skills. Cooperative learning relies heavily on students' interaction with their peers, as students will work together as a group to help motivate and challenge each other to maximize their learning. Discussion within the group can help students to consolidate their thinking and learning from different perspectives to extend their scientific knowledge. Teachers' role in these two teaching approaches are equally important in students' learning. The teacher is responsible for facilitating discussion within group and challenging students' thinking. Furthermore, the teacher needs to help students construct meaning in their learning by guiding them to build connection to real-life situation. And most importantly, teachers need to actively encourage learners to be involved and engage with their learning. For the explore activity, informal assessments such as observation from teachers can be done for understanding students respond using the prompt questions or the conversation with their peers. Teacher can also use this opportunity to clarify any alternative conception students may have regarding soil erosion. We have also included a formative assessment worksheet about the experiment for students, where students are asked to make prediction, record observation, and also extend their thinking. Teacher will have the opportunity to collect the worksheet at the end to examine the student's response and make adjustment to future lessons.
For the explain activity, we also use informal assessments similar to the explore activity, as teachers can assess student learning through a discussion, sub-questions, and open-ended questions for students, such as, what do you think would happen to the soil if this human activity didn't happen? Instead of, is a human activity going to cause soil erosion? Eliciting a no or yes answer. Secondly, the poster allows the teacher to know where students are at in their understanding of soil erosion and human impact. Finally, students will have a reflection activity to monitor student learning and inform future lessons. For more details, you can download the assessment task for the two activities using the QR code on the right. We have also incorporated IBL and cooperative learning in our formative assessments through opportunities for students to inquire and discuss knowledge of soil erosion and to clarify alternative conceptions, or AC. In the explore phase, an abstract worksheet was chosen to consolidate students' learning after the experiment, which researchers find effective for holding students accountable for their learning and addresses the AC that soil erosion is not a very serious environmental problem. To build on this, the explain phase had a poster which allowed the teachers to then monitor if students understood that human activity causes soil erosion, find practical solutions to it, address that soil erosion does not only happen in the past, and that humans do have control over soil erosion rate. By addressing these ACs, we enable students to become geological change makers to take small actions for the environment. Overall, these two activities provided multiple opportunities for informal feedback, which ultimately leads to an awareness of soil erosion, builds towards a summative assessment, and allows a teacher to broaden ways of thinking about soil erosion, scientific knowledge, and the product of science.
According to the Australian Professional Teaching Standards 1.2 and 1.3, it is crucial for teachers to understand how students learn. Hence, creating an environment that includes every learner by addressing students' needs, strengths, and differences is important. For example, to cater for learners with different learning styles or disabilities, teacher can provide various modes of instruction, such as worksheets, slides, or demonstration prior to the activity, to ensure that all students have a clear understanding on what is required for them to do and engage with the activities. In a classroom with varied learning levels, using mixed ability groups or teachers group during experiment or poster research can allow each student to build their confidence as well as a chance to extend their scientific knowledge. Teacher can also include prompting or extending tasks to help scaffold or challenge students' thinking. With these strategies, they will help create a science classroom that is inclusive to all learners, and we hope that all our activities will provide teachers with a resource to teach students about soil erosion that will help foster geological change makers of the 21st century. Thank you.
Thank you.